Imagine reading a novel that consists only of its final chapter. What value would there be in reading a story like that? We all know books aren't just about how they end, they're about how they unfold and the lessons you learn along the way. The same is actually true about climate science. Today we stand in a very uncertain chapter of Earth's climate history. And as we look around at rising emissions and unpredictable weather patterns, we're asking ourselves, how did we get here? But also, how do we know what's coming next? One of the only things we know for certain is the effects of climate change are going to be felt unequally across the globe. And some of the most vulnerable communities in the world are in tropical East Africa. This is a region that's experienced worsening climate disasters in recent decades, but scientists remain uncertain about how local systems there are going to respond to global change. So my work as a paleoclimatologist tries to resolve this uncertainty by taking us far back in the geologic past, close to the beginning of this climate story over 1 million years in the making. But instead of reading words off of a page to do this, I read ancient organic molecules that are preserved in mud at the bottom of Lake Malawi. Lake Malawi is one of the largest lakes in the world. It's a biodiversity hotspot, it's a region home to millions of people, and it's had a sediment core collected from its bottom that spans nearly 1.4 million years of Earth history. In the lab, I extract organic molecules from each layer of this mud, and then I analyze those molecules on a range of mass spectrometers to learn about ancient climates. I look at the molecular remains of plants, whose chemical signatures can tell us how much rain fell in the past. And I study microbial membranes, whose distribution in mud can record ancient temperatures down to the degree. I've even developed new ways of reconstructing ancient temperature so that our methods at Malawi can be applied to sites all over the world. In short, we're translating a molecular history of one lake into the story of East African climate as a whole. And our record captures important events of Earth's climate past that can help us understand the future, like ice ages and the environment that allowed humans to first evolve, as well as periods of global warmth so extreme that the ice sheets now covering Greenland and West Antarctica had completely melted away. Those ancient chapters of Earth history give us the context to understand how local systems in East Africa respond to abrupt and extreme global change. Through this, we can help climate modelers make more accurate predictions of what's to come, and so that scientists can work alongside local community members in developing effective and proactive mitigation strategies, so that all of us can turn away from this chapter of climate uncertainty and start a new one together of adaptation, resilience, and hope. Thank you.